Hello everyone. Today we'll be covering CIE A-Level Physics, May June 18, Paper 12, Question 10. This is an MCQ question that was found not correctly answered by majority of the candidates that sat the exam this year. If you're keen on trying the question out yourself, feel free to pause the video and give it an attempt. If you want to check your solution, feel free to skip towards the end of the video to see whether you've gotten the right answer or not. If you were unable to do it, that is fine. This is the solution. So the density of water, no wait, before that, let's analyze all the data that we've been given. So the density of water, which is 1 grams per centimeter cube, and the density of glycerine. I'll be using the notation G for density of glycerine. So water is added to a measuring cylinder containing 40 centimeter cube of glycerine, so Vg. So the density of the mixture is 1.1 grams per centimeter cube. Assume that the mixing process does not change the total volume. So assume that the total volume, which is the sum of volume of water and volume of glycerine, does not change after, mixing, which is the case sometimes, but we're made to assume that it doesn't. So what is the volume of water that will be added? So we're supposed to find out the volume of water, right? So to make this easier, because all the data is spread out everywhere, let's make this easier for ourselves and note down all the data that we've been given. So the density of water, which is sort of universal, and density of glycerine, the volume of glycerine, which is 40 centimeter cube, and we will also need the mass of glycerine. But don't mistake this for mg as mass into gravitational acceleration. By mg here I mean the mass of glycerine. And that you'll find by the formula rho is equal to m by v. So you make m the subject of the formula, so rho into v, which is 40 times 1.3, which is 52 grams, right? And the mass of water, which we haven't been given. So the volume of the mixture, the density of the mixture follows this equation: the mass of water plus the mass of glycerine divided by the volume of water plus the volume of glycerine, right? So you'll see that two of the things over here we've already been given, which is the mass of glycerine and the volume of glycerine. So rho m becomes 52 plus mass of water divided by 40 plus volume of water, right? And you have to see that we're supposed to find everything in terms of the volume, right? So how would you find the mass of water? Well, you just make m the subject of the equation. So it becomes m is equal to rho times v, right? Therefore 52 plus rho of water, v of water, divided by 40 plus the volume of water. Now over here you could go into the formula and make VW the subject and calculate a value for the volume of water that's added. However, I found that the easiest way to do it without getting into much complication is just do trial and error. By trial and error, I mean substitute each of these volumes into this equation, and the one that makes the density of the mixture as 1.1 grams per centimeter cube will be the correct answer for the volume of water, which is, well, D, if you do it by trial and error. But if you don't want to do it by trial and error and want to go into further explanation, let's work that out here. So you've been given that 1.1 is equal to 52 plus rho v divided by 40 plus volume of water. Now you know this is 1, right? So you just ignore this. So you bring this here. So 1.1 times 40 plus volume of water is equal to 52 plus volume of water, right? So 1.1 times 40, which is 44. 44 plus 1.1 volume of water is equal to 52 plus volume of water. Therefore, volume of water, when you make it the subject, so you bring this here, you bring this here, so 52 minus 44, which will give you 8, divided by 1.1 minus 1, which was 0.1. So the volume of water, you get it as 80 centimeter cube. So you can do it by either way, either methods, but this would save much more time. I hope you understood. If you have any doubts, please do leave them in the comment section below.